Passage 4 is a research passage that is discussing concentrations. It talks about how hypotonic solutions is when the dissolved particle concentration is lower, and hypertonic solutions when you have a dissolved concentration that is higher. And so you have water move from hypotonic environments to hypertonic environments. And they did some experiments. Experiment 1, they soaked some beans in water for 30 minutes, and they looked at the mass before they soaked them and the mass after. They were soaked for 30 minutes at 20 degrees Celsius. And you should notice that the mass went up, but not much. And experiment 2, they did the same thing, exact same thing, but they did it for 8 hours instead of 30 minutes. So one of the things you may notice off the bat is that the mass is much, much bigger than it was in experiment 1. And then in experiment 3, they took the seeds from experiment 2 and then soaked them for 8 hours in a 5% salt solution and did the same thing, found the mass afterwards, and you should notice that the mass went down, so it was the opposite effect. For number 18, it says in experiment 2, there's a net movement of water where? So in experiment 2, net movement of water, well, since the mass is going up for all of these, the initial mass is always less than the final mass for the 6 beans that they collected data for. That must mean that water was moving into the bean seeds because mass was increasing. If you're adding water, you're adding mass. So 18 was J. 19 says, in which of the following ways were the designs of experiments 1 and 2 similar? So A is not correct. They used new beans. The soaking time was not 30 minutes for each. One was 30 and one was 60. Right, this one says 30. And this one was for, 8 hours, sorry. 30 minutes and then 8 hours. The final mass of the bean seeds were the same. That is definitely not true. The temperature of the water is the same. Now it mentions the temperature in experiment 1. It doesn't mention the temperature in experiment 2, but it says that experiment 1 was repeated, and the only difference was times. So you can assume that the temperature was also the same for experiment 2. For number 20, in which of the following ways did experiment 3 differ from experiment 2? In experiment 3, the bean seeds were soaked in salt water. In experiments 1 and 2, they were using distilled water. They were soaked in distilled water for both experiment 1 and experiment 2. The difference is in experiment 3, it says they were soaked in a salt solution. So number 20 was H. Number 21 says that a 1% solution of sugar in water is poured into side A of an empty U-tube, like that shown in figure 1, and distilled water is poured into side B. Will there be a net movement of water across the membrane? So you should notice that 1% sugar solution is going to be different than distilled water, which is 100% water. So the concentrations are different, not by much, but they're different. And so it mentions in the beginning that particles will move when the concentrations aren't equal, and they're going to move. You'll have water movement until the concentrations are equal. So you would have movement because the concentration is different. Number 22 says, at the beginning of which of the following experiments, if any, was the soaking liquid used in the experiment isotonic relative to the bean seeds used in that same experiment? So if something's isotonic, that means the concentrations are the same, which means there wouldn't be any movement. So it would show no change in mass. If water is not moving because the solutions are isotonic, then you won't see any change in mass. So for all the experiments, the initial mass and the final mass was always different. There's always a difference between the initial mass and the final mass. So there's always movement of water somewhere. So there was no experiment where the liquid and the beans were isotonic, because there was no experiment where the masses were identical before and after. So number 22 is J. Number 23 It says, based on the information presented, in which of the following U tubes will there be a net movement of water from side A, or I'm sorry, from side B to side A? So one of the things that I did is I labeled based on the percents of the solutions it was telling me, or the percent of the dissolved particles. I wrote here, you can see my numbers here. These are that's the percentage of water. And water is going to be moving from high concentrations to low concentrations. Or you're going to have water move from hypotonic to hypertonic environments like it shows in this figure on the front. So I need to find where I would move from B to A. In C, you would move from A to B. You would move from the water would move from the hypotonic solution on the left to the hypertonic solution on the right. A is not going to work because you have an isotonic environment, right? So you're going to have no movement. In letter B, you would have movement from side B to side A because side B is hypotonic, side A is hypertonic, so water would move from B to A, which is what it was asking for. So number 23 was B, and letter D, just like letter C, you would have movement, but it's from A to B, and the question was asking for B to A. So letter D wouldn't work. So 23 was B. It was the only scenario where you would move from water would move from B to A, from hypotonic 100% distilled water to a hypertonic solution of 10% salt water. For 24, based on the information presented, one can conclude that the distilled water used in experiment 1 was what? And so one of the things you can do is you can eliminate letters F and G because it's talking about the solution used in experiment 2, and answer choice is F and G. Now, in experiment 2, distilled water was used. So they're talking about the distilled water in experiment 1 being different from experiment 2. That can't be right. They're isotonic. So F and G are not good answers. And distilled water is 100% water. And the solution in experiment 3 was 5% salt, or the other 95% would be water. So the water from experiment 1, which was 100%, would be hypotonic because it doesn't have any salt in it. Right? It has a lower concentration of dissolved particles. So number 24 was H.